Good morning, students. Today we are going to solve the examples in maxima and minima. Examples in maxima and minima. So, example 29 are given in the textbook. Find, don't be thinking about this. Find all points of local maxima and local minima of the function. Find local maxima and local minima of the function. F is given by f of x is equal to x cube minus 3x plus 3. He given polynomial function. So, we are following the step like our increasing decreasing function method. What we are doing, guys? We have f of x is equal to x cube minus 3x plus 3. First derivative of the function. First derivative of the function. F dash of x is equal to 3x square minus 3. Take 3 common. X square minus 1. This is a square minus b square. A square minus b square means we can write a plus b into a minus b. Now the first step is apply the condition. First derivative is equal to 0 means what do you get? We will get critical points. From this we will get the critical point. One is minus 1 and second one is plus 1. So by taking this critical point, we are going to divide the real number line. We are going to divide the real number line into different intervals. Different means disjoint intervals or different intervals. One is a minus infinity comma minus 1 and second one is minus 1 comma 1. Third one is 1 comma infinity. After that what we have to do? Check the first derivative condition. F dash of x in between any number. Consider minus 2. Consider minus 2 means minus 2 plus 1. Minus will come. Minus 2 minus 1. Minus 3. Minus into minus plus. Become plus. So value is plus. Whatever negative values if you consider between minus into minus, the first derivative function which gives positive only. That's why I written greater than 0. Minus 1 to 1. Take 0. Just consider 0. 0 means 0 plus 1 plus 1. 0 minus 1 minus 1. Plus into minus minus. That's why less than 0. And take any positive value like 2. Like 2. 2 plus 1 3. 2 minus 1 1. All plus values only. Again greater than 0. Okay students. Here up to here the whatever we did in increase and decreasing function, the same method we applied up to here. Here the new thing is what we are telling means I said this is plus and this is minus and this is plus. But okay, plus changing into minus. The plus changing into minus. Plus changing into minus means we get the maximum. What type of maximum? Local maxima. And where it is shifting, that means here plus is there, here minus is there. Plus changing into minus happening at in this point, that is the local maxima point. Local maxima point. So local maxima point is minus 1. By using that point, otherwise put that point in f of x given value. What do you get, Nana? Local maximum value will get. Local maximum value it comes. So f of minus 1 is equal to, I written minus 1 whole cube minus 3 into minus 1 plus 3 is finally. By simplifying this, we will get 5. And the next one is the minus is changing into plus. The second action is here plus means minus changing into plus means what we get, Nana? Minimum. Local minimum point is 1. Then calculate f of 1. What is f of 1? What is f of minus? Local minimum value. F of minus means local maximum value. So he given minimum of the local maximum minimum means just mention the points which is local maximum point and local minimum point. Then calculate local maximum value and local minimum value. This is the solution for this. So generally here in step 4 in increasing decreasing function what we are writing means greater than 0 means the given function is increasing on interval of this part and also union here and decreasing on here, like that we are mentioning. But here where the plus is changing into minus, there we will get the local maxima, and the minus changing into plus, there we will get the local minima. So understand it and note down these points. Next example, students. Find all the points of local maxima and local minima. Local minima of the function f is given by f of x is equal to 2x cube minus 6x square plus 6x plus 5. We have f of x is equal to 2x cube minus 6x square plus 6x plus 5. Differentiate of the function f dash of x means 2 into x cube derivative 3x square, totally 6x square, minus 6 into x square derivative 2x, totally minus 12x. 6 into 1 6, 0. Finally 6x square minus 12x plus 6. Take 6 common, x square minus 2x plus 1, and this expression is look like a square minus 2ab plus b square. We can write a minus b whole square. We can write a minus b whole square. Now step 1. First derivative is equal to 0. That means 6 into x minus 1 whole square equal to 0 means obviously what do you get? X is equal to 1. We will get only 1 point. So then step 2. That one critical point divides the real number into two disjoint intervals. Minus infinity comma 1 comma infinity. And check this. F dash of x minus infinity comma 1 is just take any number 0. 0 minus 1 means minus 1 whole square plus 1. Positive. Any number if you consider positive, that means greater than 0. Take any value. Here also you will get the positive because the expression has a perfect square. The expression has the power 2. Power 2 means if you get some negative also, if you are getting negative also, it becomes positive. It will become positive. That's why both are getting the greater than 0 only. Greater than 0 means what is the condition? Plus changing into plus or minus changing into minus. What do you say? That such type of condition, what do you say means it is inflection point. Inflection point means neither local maxima nor local minima of the function. We cannot get any local maxima and local minima. We cannot get any local maxima and local minima. This is a inflection point at where 1. So there we cannot get any local maxima and local minima. This is the solution for it. Guys, observe it. Plus value changing into minus, local maxima will come. Minus value changing into plus value, local minimum will come. Plus changing into plus or minus changing into minus will not get any local maxima and local minima. Such condition is called the inflection point. Previously what we are calling is a critical point. If nothing is happened at that particular point, that point is the inflection point. At that time, the function is, what do you have to write? Neither local maxima nor local minima for the function. Students, next example 31. Find local minimum value of the function. Here he is asking only one value, guys. Local minimum value. Local minimum value f is given by f of x is equal to 3 plus mod x is belongs to R. X is belongs to R means in previous problem he doesn't mention that word. X belongs to R. Now he mentioned it. Let me, we are taking the real number only, and generally you know that modulus function in first year. Modulus function means from here it will comes like a V shape. But he given the 3 minus x means it comes at third 3 point. When x equal to 0, y is equal to 3 now. That's why it comes here. So, what we know? 3 plus mod x means we have one condition. What is that? When x is less than 0, mod x behave like a minus x. When x is greater than 0, mod x behave like a plus x. Mod x behave like a plus x. By taking this condition, now we are writing x is less than 0 means f of x behave like a 3 minus x, the function. And x is greater than 0 means f of x is equal to 3 plus x. F of x is equal to 3 plus x. Now take this one. That's why I am not written any step 1, step 2. So simple calculation only because he asked for 1 1. So our critical point should feel like a 0 1. Our critical point should be considered as a 0. Why, sir? How do you know 0 is the means? Because he mentioned the modulus function. I said if he given modulus function, wait a minute, there x less than 0, x greater than if you consider means sufficient to that. That's why simply I written left to 0. That means left to 0 means 0 less part, x less than 0 means. f dash of x, what will happen Anna? Derivative of this function, constant derivative, minus 1 will come, minus 1 will come. So minus comes. Minus means f dash of x, what will happen? Less than 0. And right to 0, greater than side, this side. First derivative of the function, f dash of x is 1 plus 1. F dash of x is greater than 1. What happened guys? This is minus and this is plus. Minus changing into plus. Minus changing into plus. Minus changing into plus means minimum will come. The minimum critical point is nothing but 0. So local minimum point is 0. Local minimum value means the 0. Put in the function, given function, this one. Keeping 0 means for 0, no plus and no minus. So 3 plus 0 means 3 will come. That is the local minimum value for this function. Local minimum value for this function. No doubt. Students, next 32 example. Find local maximum and local minimum values of the function f is given by f of x is equal to 3x to the power of 4 plus 4x cube minus 12x square plus 2. Okay, take the steps. Derivative of the function. What do you get? 12x cube plus 12x square minus 24x 0. And first step, take the condition f dash of x equal to 0. So in this, take 12x common, you will get x square plus x minus 2 equal to 0. And 12x into x square, they make it into factors. Making it into factors. What you will get finally? X equal to 0, x equal to minus 2, x equal to 1. Finally, we got the three critical points. By taking the critical points, the real number line divided into 4 disjoint intervals. F dash of x minus m means less than 0, greater than 0, less than 0, greater than 0. Students, we have more of them. But he asked only local maximum and local minimum values is asked. Suppose minus 2 plus, actually this is minus plus, minus 2 plus means local minimum point will come, that is minus 2. Local minimum value point minus 2. And plus 2 minus means maximum. That means at 0, maximum point will come. Again, minus 2 plus 1, local minimum. And okay now, like that. So here minus 2 and plus 1, both are the minimum values, local minimum values. And this is the 0 is the maximum. So finally, local maximum is 2. In this, which is the smallest value? Actually, in out of the local minimum values, which is the smallest value? Minus 30 is the smallest value. So what do you write means local minimum value is minus 30, local maximum plus 2 you can consider. And actually, in all local maximum minimum values, which is the highest maximum, that is called the absolute maximum, which is the smallest value, that is the absolute minimum. But here he doesn't ask the word of absolute maximum or absolute minimum. Just he asks by calculating that which is the highest value, that should be considered local maximum. Nothing will happen. Which is the smallest value, that should be considered as a local minimum value. Note down like this. Give the students, next 34th problem. Find two positive numbers whose sum is 50 and the sum of whose square is minimum. Students, 5 marks question in maxima minima. 5 marks question. What type of model it comes in 5 marks means? This is one of the problem. If you observe previous year's papers, it will appear in that. It was there actually. And how we have to find out this problem? Find two positive numbers whose sum is 15 and given one quantity. The steps are there now to prove, to find. So like that, just understand this concept. Sum is 15 and the sum of whose squares is minimum. He is asking sum of whose square is minimum. That means here how we have to consider is let one of the number is x. Because we don't know the numbers. One of the number is x means sum of the two numbers means just consider two variables means x plus y is equal to 15. Y is equal to 15 minus x. Actually what I consider first number is x, second number is y. Y is nothing but 15 minus. That's why directly let one of the number is x. Other number is 15 minus x. 15 minus x. Clear? And what I am telling is s of x. That means we should make a formula, injure formula, to injure a formula in one variable. I said concept yesterday. Let s of x denote the sum of the squares of these numbers. Sum of squares of these numbers. What is the meaning of function x square plus 15? Because first number square plus square of second number 15 minus x. Just go for the first derivative. First derivative means derivative of x square is 2x. Derivative of 15 minus x square means 2 into 15 minus x, and again derivative of 15 minus x means minus will come. So just take this, we will get the 4x minus 30. We will get 4x minus. Then come to the condition. First derivative equal to 0 means we will get the critical point. 4x minus 30 equal to 0. X is equal to 30 by 4. 15 by 2 will come. Students, maximum, not local maximum, not. Just he is asking about the, it is minimum. Just prove it to find out the minimum of this. So for that, what means in this concept you have to use the double derivative test. Double derivative, second derivative test. So go for the first. This is the first derivative. S dash x. S double dash of x. Sorry. S double dash. S double dash means again one more time differentiate of this function. 4 into 1, this is a 0. 4 will come. So in the place we have to substitute the critical point. S double dash of 15 by 2 is equal to 4. 15 by 2 equal to 4. 4 is the positive value. 4 is the positive. Positive means greater than 0. Double derivative term is greater than 0 means what will come down? Minimum will come. Discuss it. F double dash of x is greater than 0 means minimum value will come. And f double dash of x less than 0 means maximum value will come. So the sum of whose squares is minimum at x is equal to 15 by 2. Finally, one of the number is 15 by 2. Other number is 15 minus 15 by 2. Final answer 15 by 2. I just find two numbers and also I shown the minimum at x equal to 15 by 2. Student, next 35 example. Find the shortest distance of the point 0, c from the parabola y is equal to x square. So this is x square equal to 4ay parabola. X square equal to 4ay means upside will come. Okay, let me. Where c value, this c value is like between 1 by 2 less than or equal to 5. Okay guys. Just what I am doing means I want to consider a locus point on this curve. I want to be consider a locus point on this curve y is equal to x square. Let h comma k be any point on the parabola y is equal to x square. Let d, I want to one letter for making a formula to that. D be the required distance between h comma k and 0 comma. H comma k is lie on the parabola. 0 comma c is outside. Now we are taking the distance between these 2 points. Already know the distance formula is root of x1 minus x2 whole square plus y1 minus y whole square. What you will get? H square plus k minus c whole square will come. Consider as a equation 1. And one more condition what you have to means Since h comma k lies on the parabola y is equal to x square. If any point lie on the parabola curve means instead of x coordinate y coordinate you can use these letters also. This is the belongs to the x and this is the belongs to y. That's why k is equal to h square. K is equal to h square or h square equal to k. Instead of h square, just we have to take k. Y sir, why we are doing? I said to injure a formula should make it into one variable. But here in this formula, two variables are there, h and k. But what we are doing by taking this condition, we are making it to single letter variable. That's why now d of k means it is a function like f of k, f of k. F of k equals square root of k plus k minus c whole square, and go for the differentiate. Differentiate means root derivative 1 by 2 root x, 1 by 2 root of k plus k minus c whole square with respect to k now. And k derivative is 1. K minus c whole square is 2x. X square derivative 2x. Now we got this expression. And finally what we do? After doing the first derivative test, go for the first derivative is equal to 0. I calculate that. Finally we got the critical point. We got the critical k is equal to 2c minus 1 by 2. Problem not completed, only one step only completed. Just note down this, then I will continue the later. Okay, next continuation, Anna. We got the critical point. Generally, in such type of problem, what we have to do? We have to go for the double derivative test. Generally, if you observe that when k is actually k is 2c minus 1 by 2. Suppose k value is very smallest means, obviously k is very smallest value means definitely d dash of k, first derivative definitely less than 0. And k is greater than of 2c minus 1 means definitely d dash of k is equal to greater than 0. Double derivative means again it comes big value Ramana. So no problem. It is gives k is equal to 2c minus 2 means then you can apply this one minimum d dash of k is greater than 0 or double derivative of k is less than 0 and double derivative of k is greater than 0. Finally d of k is minimum because already I said double derivative of the function is greater than 0 means minimum comes. Double derivative of function is less than 0. So what you do means minimum at k is equal to 2c minus 1 to find a required shortest distance is equal to be calculated like this. Students, in this problem, first make a formula. That means make a formula in one variable. After that, go for the first derivative which is equal to 0. You will get the critical point. If you are doing double derivative means again it gives much expansion. Further, we are taking the shortcut here. When k is less than 2c, definitely that double derivative function which gives less than 0 only, and k is greater than means double derivative value which gives greater than. Not like that. No need of write this. Simple. What you do for this part, you go for the double derivative. For this part, you go for the double derivative. The double derivative comes like this. In the place of k, just substitute it. It comes positive value means greater than 0. It comes negative means less than. Definitely, it comes as a positive value. Positive value means greater than 0. So finally, it is minimum at k is equal to 2c minus 1 by 2. Finally, shortest distance is like that. Clear, Nana? Okay. Just given a simple local maximum, local minimum, and maximum minimum, and somewhat picturization. Picture-wise, that means sphere cone related problems are there. Tomorrow I will get explanation of the one or two problems and examples, and I will enter into exercise problems also. Students, today at least you have to complete this. And one more thing, every time I am telling you, purchase textbook. Everyone should purchase textbook. Without textbook, whatever I am explaining also, if If you want any reference means there is no reference. Now it is somewhat given relaxation na. Just move and go and get it. Okay guys, thank you.